Hello, for today's class is our lecture of CSCI 352. And for today, we will do some perform some network analysis. So we introduce related to some network, okay? And just like we will go through some maybe the truth and then some like basic concept related to the network analysis. Of course, like as a beginning, we need to have some basic understanding related to the network packet. Okay, so when we have a connection between like maybe end to end or client to server, okay, or when we request certain information, so always there's a packet, okay, sending out. So we need to know how can we analyze, okay, those package. Okay, so once we start the communication, that means there's a traffic. Okay, so that how can we analyze the traffic? And we have the gateway, so including the router. Okay, so how can we do the router or like firewall? Okay, so for the forensics. Okay, so this will be the mainly we can cover as a beginning. For today, we talk about the packet, right? So we need to know the packet for our sending out. Okay, so including there's a part is including the header and then the payload. Payload pretty straightforward, is about your data. So all the variable. Okay, so if you are this if you talk maybe web programming and then or other courses, if you learn like when you try to post, okay, there's a method like post, right? So you post certain data to the server, so you will like contain in the payload. Okay, so those are, or sometimes when you get, okay, so when you get something, actually there's all the data will start in the payload. Then we only having the data is not enough, so we need to have the header. Okay, so the header contains like the source port, okay, and then the destination port. So this one is knowing when we doing the learning cybersecurity, you know the different port for different application. Okay, for HTTP, so it will go to like port 80 with like HTTPS like 443, and then maybe with the FTP. Okay, so for different type of application, okay, service we use different port. Okay, so the one from which the source port and into the destination port, and therefore sequence number. And the reason why, one of the reason we need to have the sequence number. So it's like just like preventing replay, but this one you learn later. And then also we have an acknowledgement number. So we say we have an acknowledgement number, and then the data offset, okay, and including the reserve flag checksum. So if you on the checksum, so we're doing, and then maybe where's the window or the urgent form pointer. So all these are some other options are pending. So all these will combine as a header. Okay, so you see there's a structure of a packet. Okay, and if we look at it, we have the Ethernet header. So they will actually they are multiple packets together. So if you need to send a package packet like, oh, okay, so you for the Ethernet header, so Ethernet level. So right here we need to have a source MAC address. Okay, so destination MAC. Okay, so right here, so we mainly care about the MAC. And then for the IP, okay, so we care about the IP. So where's the IP address, and then which protocol are they using? Okay, the protocol, and it will see the TCP IP. Okay, so right, so this one is the TCP header, so including the port, we say a sequence number, and then the data. So there's like the all the package like header like combined together. So in each level, okay, so if you know like from our sending out from the application level and goes down to the physical level. So that's how it looks like, but mainly is like under the network level. Okay, so they're packed. And there's a like for TCP header, so there are some like header bit. Okay, so including the URG. So they one will be for urgent. Who remember like if the traffic then marked as urgent. Okay, but this one is like very used. Okay, ACK. So you see ACK is the acknowledge to obtain a synchronous communication. So for we set up the communication, is that with the our maybe most pretty common is like three-way handshake. Okay, so we were sending the acknowledgement, receive it, and sometimes we need to like reset it. Okay, if for sometimes for the connection we need to reset it, so we send our RST synchronize sequence number SYN and file FIN. So this indicate no more data from the sender. Okay, so all these will like added in the TCP header, so will be the bit, okay, content. As well, we say like the TCP we have a three-way handshake, right? So we're sending the synchronize, okay, go to the server, okay, send to server and destination, and then the destination server will reply with the synchronize and the ACK acknowledgement back to the host. Okay, so you say, and after we receive it, so you return the acknowledgement back to the server. Okay, so that means we went to the three-way handshake. Then say, okay, just like imagining the way I want to talk to the server. You say hello. Okay, so say okay, I'm ready. You can come to bed. Okay, then I say okay. Then we start to talk. So it's called a three-way handshake. Then we can start to sending the package. That will be contain all the payload content you would like to send. Okay. And if you need to terminate, so there's one more. So right here, if you remember, like if I need to terminate, so I will sending the acknowledge. So here's different, right? Because I need to synchronize, right? You remember for this time, I just like sending acknowledgement and acknowledge with the FIN. So finish up right here to the server, and then server, okay, I received yours. So I send acknowledge back to the host. Also, I also make the send another acknowledgement and then finish to the host. Okay, again. So right here we are like sending slightly different. So and the host said, okay, we are going to terminate. We have finished the connection. So I send the acknowledgement back to the server. So it will showing the connection will be terminated. Okay, so here's the way. And if we need to scanning the FIN, that means that okay, it's like I'm finished. So we can like send the FIN to the server. And if there are no spawn, then it goes back. So this is like one of the very common way to scan the FIN. And this one is called the Christmas tree scan. Okay, so including what kind of thing, the finished version. Okay, BSH right here. So sending to the server. And then if the server like can like return it, so we send it we reset back to the host, then we can reset the connection. So that's how it looks like. And how about the now scan? So we just like sending a now. Okay, so now scan just sending all the empty content, and then send to server. We send the reset back to the host. So here's the way. You just need to know, okay, for different name. Okay, let's say start from the beginning, FIN finish scan, or start from the three-way handshake. Okay, and then TCP connection termination, and then the FIN scan, Christmas tree scan. Okay, so including the three finish, origin, and push. Okay, they send you server and return the reset. And we have the now scan. That means that 6-bit now representing in this way and return the reset. Okay, and then we have the network packet, okay, in the payload. So this is mainly is the body or the content like of the package. So it's the actual content so of the packet delivered to the destination. So if the packet is the fixed length, then the payload may be like pattern with some like brand information or specific pattern. So make it the right size. So here's the idea. So if you remember, we have the pattern. So this one is the helping to make it have a fixed size. And then we have the trader. So so this one it contains the error check data to detect the error. So when they like occurred during the transmission. So maybe part of the Ethernet or the point-to-point protocol PPP, okay, frame, or other level layer 2, okay, the layer 2 protocol. So they will contain in the error checking data. And here the cynical redundancy check, the CRC. So right here will be preamble, and then do a destination address, source address type data, and then we will contain CRC. So if we find the CRC, okay, so that means that this frame will be discarded. So it's like then they ask a question like they will just like put the trader, but in trader rather than the header. So it's just like maybe it's just like we call it the redundancy check. So we because like when we add it in the header, that means like okay, that means we know we exist. But for the checking, then we will unpack it, so we know okay, it going to the discard. So there's sometimes that we have to check it and add it. Okay, so it's the idea. And then of course we have the port. So the port will be there's a number identify the channel, like which communication can occur. Okay, so total we have 65,635 possible ports. So some knowing like some ports they are destined for, okay, or coming from. So we tell you, so you know which protocol was using. So they're pretty common. So here some like really important part, or like if we doing the analysis, okay, investigation, then it's pretty easy to find. Okay, so if we are looking for the FTP file transfer protocol 2021 secure share SSH. So if you know like always you kind of using SSH, we using 22 or Telnet 23 and SMTP using 25, but also why not we have encrypted. Okay, and then we have the domain name server DNS at 53 HTML will be the 80, and then also the POP3, the post office protocol. Okay, so it will be 110. Of course, we are more like new version, so we can find and something else. So maybe we have other like utilities you can use, and you don't have to like really memorize all this. Okay, so just have some idea, but you need to know this port maybe like on the intruder port. Okay, so maybe like 43.188 which are bad. Okay, or download it or right here, or like BO2K. So right here some polypods. So if we try to check, okay, and then another one is the DDoS attack, or sometimes we say the DDoS is okay. So for DDoS is more like distributed, so it's the same. Okay, so it can target at a given server, so it will increase the traffic, affect the rest of the target network. So the attacker using we call the network with the malicious package. So they keep sending to it. So they try to preventing the legitimate like network traffic from like passing. So they maybe use one of these like three approach. So either they try to damage the target machine ability to operate, or try to overthrow the target machine with the open connection at the same time. Also, they try to use the bandwidth to the target machine. So there's a either one of approach. So when they try to ping the death attack, so we like this, if you remember, in cybersecurity, we try to like simulate how the DOS. Okay, so for distributed, that means we have multiple. So when we say DOS, we can just think in one. So we're sending the IP header, if you remember, ICMP header, and then with the data. So 20 bytes, 8 bytes, and then this one more than like 65, but like 507. So right here, so send to the server. So it will try to use it. And for the attacker, if we have some like switch router, so boxes address, then we can like this one. For the painful, that means that we try to send to every connected devices. Okay, so I don't care which is the destination. So I just send to all the connected devices. Okay, like this, like all the host. Okay, and the teardrops attack. So this one can send fragments of packet. So what the like bad value in them. Okay, so the idea is like try to cause it to like crash when it try to like resemble the fragment. Okay, so actually the fragment of the packet just like breakdown is like if you know the fragmentation. So we just like break down to pieces of pieces. And then if there's some like bad value, so they have a crash because they cannot reassemble the fragments together. So here's the idea. So they're done. And then they have the synchronous cipher attack. So for the attacker, so if you remember, like we try to synchronize, you're saying it, and then the server will reply the synchronous and acknowledgement back. But you instead of just like sending an acknowledgement to start the communication, you just like send the the synchronize again back to the server again, and then the server have to reply it as a synchronized acknowledgement. So you just like repeating this step like forever. Okay, so you use all the resources of the server. So here's the idea. And the LAN attack, so it's saying, so if the attacker try to send a fake TCP synchronized packet to with the same source and then destination IP address and port as a target computer. Okay, so the victim computer like we trick like in thinking, okay, send a message to itself because like the packet coming from the outside, so they use the computer's own IP address. So they got the LAN attack. So here's the idea. Smooth attack, so will be the smooth attack will be the attacker try to send it through the network, and then the network go to the like some amplifier. So amplification, that means we went to others devices, and this device then will sending all the acknowledgement and then synchronize it to the server. So instead of using your own computer, so you just like went to the other intermediate nodes, okay, and then they will amplify this attack. Burger attack, so it's pretty similar, but this one using a spoof user datagram, so protocol UDP. So if you remember the UDP, so packet, so instead of the ICMP, so using the Internet Control Message Protocol, so it just like echo the replies. So this one can like open up bypass firewall. So it's more like, because I don't care the connection, I just like keep sending the packet. So it's the spoofing, okay. And also the packet is mistreating. So once it occurs, so when the compromised router so mishandle the packet, so it will cause a conjunction. So in a part of the network, so it cause the packet mistreat. Okay, and in the network traffic analysis, like when we look at it, so one part like we need to monitor the network. Okay, so we just looking for the whole pictures of it, so we know okay, from the attacker, from the unknown intermediate to the, so it is a whole picture. But for the details, if we need to analyze the network, then it will be more like details. We're looking for the actual package or the content header, or like they what they're going to do. So this is the idea. So when we have a sniffer, so for the software or hardware, they can like intercept or log the traffic passing over the digital network. So it's like this, and then we try to extract the network packet and perform the statistical analysis on the dumped information. Okay, and pretty common we can apply this one, the sniffers like including TCP dump, if you know. So it's the like for Unix platform and like the Windows or Windows like this. TCP dump so common applying for sniffer for some like the Unix platform, and we can just like have a window for the Windows platform. So both of them, they try to extract the network packet and then perform the statistical analysis on them. If you remember, like we try to have some image dump. Okay, so just like copy the image. Okay, or some like memory. Okay, so always try to copy it. And the one is always like introduced is the Wireshark. And this one is the network protocol analyzer. So it can capture some Ethernet and different protocols. So right here, so it can analyze some like real time, and then we can save the data. We can save it, and then for next time for us to analyze. Also in our previous lab, like we also use Wireshark to analyze, right? Like especially email. If you remember, we tried to look at the email, and we can run it in different platform and support like IPv4, IPv6, and also right now we have the VoIP, voice over IPs analysis. And it's pretty available, so it's pretty good. And once you execute, then you can just like capture the all the packages sending, so you can tell the frame, Ethernet, like all this content. Okay, and just like more details if you click on it. So for the hypertext transfer, so it can tell you this one is the hypertext transfer protocol. So under this protocol, there's some like data, and then of course another way, HTTP sniffer, so is another application. So you can tell you, okay, so with the numbers, time, and then from the what's the client IP, and then which port, okay, so which server IP, and what's the URL and the file like this. So all here, so it tell you what's the request header, if you know, as a language, encoding, user agent, okay, Mozilla, okay, right here. So host, so connection, okay. So all the like last modified, so all this content. And when we search, so we have some like HTTP commands using. So we have the get to read the web page, and we have the put to write, or sometimes we say update, and then post to append like payload. Okay, content delete, remove it from it, and we have the head. So this one we just like to read just the head section, and also the link to connect to existing resources, or break the unlink, so like connection between two resources. So this is a pretty common we use, and if you are follow the lab or the lecture, so you web programming, so you will see, okay, this like basic HTTP commands. And for the response message, so we always have some numbers, right? So for the range, like 100, start from 100, 200, 300, 400, and 500, we using command. And maybe for the kind error, so with 400, sometimes you see like 404, you couldn't find, so it belongs to fall into like 400 this part. And then also we have the server side. If you receive 500 internal server error, that means like there's some server side errors occur, and 300, so including the redirection. If you follow some my previous lab, like including the cybersecurity or the web programming, so when you configure the engines, I tell okay, try to redirect. So we see redirect the 300. So this one is the redirect the message. So telling the browser to go to another URL. And most common we have 200, so will be the OK message. That means like okay, wherever the browser requests the successfully process will be 200. Or for other more details, sometimes we have like 201, 202 for other information. And 100 will just like informational, so you basically just give you some information, so we'll never display to the user. So here's the message range, so it can make. And another one is the map, so you can download, so we try to capture and then scan the port. Okay, so right here, so we can use the map as not. So this one also like primarily used to as the like open source like intrusion detection system. So we can like the function, so as a WordPress package sniffer, say with a lot of configuration options. And we have the RSA net witness. Okay, right here, so we will try to analyze the first like software protocol analysis. So it can capture some like word packet, like from some like rare wide or wide or like wireless interface. That means no matter Wi-Fi or from the cables. Okay, so it can analyze some like real-time data. So through the 7 layers, okay, from the application down to physical, and we can filter some the MAC address, IP address, or some like user or more. So also it's available in different time platforms. So we look at it, and for the traffic analysis, so we're looking for some new probabilities, okay, and also like probing, okay, or the DOS attack, user to root attack, or some like remote to local attack. So this like we try to look into it. Also log file is always so helpful. So it's as a source of evidence. Okay, so it contains primary record of a person, your like all the activities, like no matter service application or this, you contain log file. So we can identify which source, nature, or time of attack, and also it can specify like which user account, and also the event related to it. Okay, so all this will be logged and saved to the log file. Okay, and for different type of logs, including authentication, application. Also, we have some operating system events, the network device security like events. All this will be like safe. If in the previous there was something that did the image of Windows, we try to looking for the authentication, right? So there's a log safe, and no matter Windows or Linux, so they all have save the log. So like if like which account going to sign in, or something for application they running, so all these like maybe error access, or this like time. Okay, so even the system event way, so all this. But even the logs of like the log file really helpful, but this one thing it changed like rapidly because it may be there's a multiple requests, so it may change every second. So also we need to get the permission to collect the evidence from some source, like even the ISP, you know, the service provider. So it takes more time. And sometimes because they need to say, okay, they have to protect the user custom privacy, so they cannot provide. So it's really hard. So they're volatile evidence, so they're so easy be like lost. Also, the attacker also can alter the logs, so including the false information. But you can log it, that means I can modify one or two lines or hide, remove it, change it to other account. So also there's a possible way. And right here for the wireless network, before we have the 802.11, right? So we have like A, B, G. Okay, so it's telling the different frequency. The first one using for the Wi-Fi, so start by also operating 5 gigahertz, and then B 2.4 indoor range 125 feet, bandwidth like 11 Mbps. Okay, and then we have the G, so it can have backward compatible to previous, and also indoor range 125, bandwidth like 54 goes up, and later we have like the AC, and so maybe long term you see it's like 11N, so it's like operating at the like 2.45 gigahertz, like up to 20 to 30 feet, and then the bandwidth can goes up to 100 to 140. Okay, and we have the IEEE standard too, so it can goes higher to like 600. Okay, or the channel say spread to streams like 40 megahertz. Okay, and they can use like multiple input or multiple outputs, so MIMO. And we have the like the 11 AC. So this one you see 11 AC, so will be up to one out of the one GPSA with the, at least like 500 Mbps, and also up to like a MIMO, so multi input multi output, and with the AD wireless like gigabyte ADN, so this one up to like 7 gigabytes you can use, and more than like 10 times faster and higher than the 11E weight. Okay, right here. And as what you heard, the number like Wi-Fi 5, 6, and previously 6, but right now actually there's more devices that work on the Wi-Fi 7. So you know the Wi-Fi 7, so there's a new standard. If you look at some numbers, they talking about how many channels, like about 2.4G, 5 5G, and even more, like right now it's like others like extend like 6. Okay, so a lot. And for the wireless networking, so we have the wall driven so this a process like for driving around, and with the passenger, so in the vehicle they try to scan for the some insecure with secure wireless network. So you see like some like public, okay, no password, so the participant then can attempt to breach the target, so they find, okay, or the wall flying, so they maybe kind of like twist on it, so just the radio control airplane. Okay, so equipped with the wall driving equipment like this, and then they have the radio control the RC plane, so can like just fly over it the target and then get the data on the wireless network. So it's like that. So it's the same idea. So we can do and just scan. So right here there's some like concern. So with the so the perpetrator use the wireless network entry point for a direct network attack, or like fix the data, so just think about it. Or like maybe the attacker, maybe they can use the third-party wireless network, so maybe the hotel hotspot, or to conceal the identity. So they also have all this concern. Okay, so of course, like we can do analysis. Just like we capture the idea. If you think, remember the email, so maybe we're looking for the MAC address, hardware. Okay, so who is that keep sending the package like this? It may help. Okay, and also for the wireless storage devices, including some digital video cameras and printer storage capacities, and then also the network attached storage NAS, and we have tablet, smartphone, also like DVR, the digital the video recorders, or like some like gaming consoles. So all this maybe also allowed to access. There's some discovery tools like you can use like the Nest and Stumble, Mac, Stumble, iStumble. So right here will be some tools like we can help to doing the analysis. And when we move it on, and then we have the router for instance. Right? So the router, so it's like one of the hardware or like we're doing routing, so software device. Okay, so to forward the packet right across the network to the destination network. So sometimes we call it the gateway or like intermediate node. Okay, so it will contain the ROM. Okay, read-only memory. So when the power on, so we self-test the code, and also they fetch the memory containing the router operating system. So you know the router itself the OS. So there's some non-volatile random access memory, the RAM, right? So contain the configuration information. When you buy the router, actually barely look at those hardware, but actually if you need to choose like which router have a better performance, sometimes you just look at the maybe what's the speed, which Wi-Fi standard they're using, but actually they do have some hardware. And also they have volatile RAM contain the routing table or log information. I remember there's a hardware is the edge router associate. It only is doing routering. Okay, so it doesn't support any like AB switching. Okay, so it just like allow for set up the firewall and then routering. Okay, so I remember that time when I touched that hardware. So they actually use the storage. Actually, they insert the kind of like USB storage for the for using as friends to storing. So because the hardware failure, sometimes they for that series, they actually for that they not quite stable. So actually can change it. So you can use like knowing, so for the hardware they can change the RAM. Okay, and for some like basic network devices, so including the network card. Okay, so far maybe for new computer you really not pay attention, but actually you're thinking, okay, I just pop in. Okay, your Ethernet cable, actually we do have the network card to connect to it, and then we have the hub. Okay, so the hub will connect the computer to the local area network, the LAN. Okay, and sending any packet it receives out to every port, just like forwarding of them. Okay, and we have the switch which can prevent the traffic jam, so it can ensure they make sure it's like connections just switch one by the connection. Okay, and then just like from origin to a proper destination. And then we have the router, so it can like connect different logical networks or subnet, or enable some traffic distinct for the networks on the other side of the router to pass through. So here's like mainly for the basic network devices we're going to use. And if we need to determine, okay, where to send the information from one computer to another computer, so maybe the router will help. Okay, and if there's some specific computer, we like send a message, and those like even other like internet user, so to the destination are 1,000 pathway like this. So it's that we call the intermediate node, or some not where you check the trace route. Okay, you see a lot. Also, it will maintain the routing table to keep track of the route. Okay, and some routes, so they are like programmed like manually, or some maybe try to learn automatically by route. So that's how the router working. Okay, and how can we attack a router? So we can try to poison the router table. So maybe we can give the incorrect router table like entries, like can result some like maybe some artificial conjunction. So maybe the overwhelm the router, or attacker say allows them access to the data in the compromise of network. So they are possible after they try to attack the router. And how can we get the evidence from the router? So always try not to shut down, because you know some variable evidence expressed solely those like volatile, you know, the volatile data will disappear. And also try not to like alter anything, and document, and always make a copy. So and maybe connect with the router once, and then commands later save it. Okay, and right here, just like recording. So it's the one of the software is called the monitor one. So we can like capture the text. So we can like doing the hyperterminal and this software. So it just like telling you, okay, what's the function? Okay, but if well, we only have the last step, so I'm not doing, but there's some router command you can check, and we have some like show the version, what's the running config, and some like startup config, and show the like IP route, or some like show the interface logging. So all these command, especially if you allow SSH to your router. Actually, most of nowadays a new router they allow you to do that. Okay, you can use the command line to get all this information. Okay, and kind of like move almost the last part. So last but not least, but will be the firewall. Okay, you know the firewall. So it's like con traffic control the device or service. Okay, so it also we can enforce the like network security policy. Okay, it can help to protect the network against some external attack or to establish the control over the network traffic, although it can prevent the conversion from the unauthorized source to protect the network system surface resources, all these. Okay, and we can like port the port and then like inbound outbound. Okay, all these we can say in using the firewall. For the network-based firewall, so this part they're saying, so we have the internal different subnets. So you span the entire the network, so it can filter all the traffic passing in and out. So right here of the network or the network segment. Okay, so we have different segments. Okay, so in passing, and for the firewall categories, so actually this one also covered in the cybersecurity. We talk like we have a packet filter. So this one as a permit or deny incoming package based on the rules. Okay, we can set up the rules. Okay, for inbound or the AK screen the firewall, and we have some like stateful packet inspection. So those like the we have the firewall and we can examine all package and consider some like previous package when they permitting or denying. So here's we can use for the state package. And when we need to collecting the data, so all the traffic goes through the firewall, so powerful connection. So it will consist like two IP address, like for communicating like with each other's. Also the top two port number, so identify the protocol or service, like type. So well known from 0 to 1023 for some like registered port, 1024 to 49151 dynamic port, and then just like beyond it. Okay, so all these, if we remember the numbers, we have the 65,536, right? So from 0 to 65535 right here. And we try to attend like on the same set of port for many different internal resources or internet resources. So due to the decode scan, and always try to check the firewall logs. Okay, we always have logs too. Okay, for some any like sort of like connection, attempted connection on those ports. So there also we can use them like protocol analysis to determine like who the attacker is. So far we just like try to summarize. Okay, so we're just telling, so we giving what's the basics like for network package and asset, we need to know the structure. Okay, and then for sending, so we have the traffic analysis, and also we talk about the what's the router and also firewall, and how can we giving you some example quickly, telling what's the forensics we can do. Well, here just I slightly give you more information with the TCP IP, so what it belongs to. So application contains the application presentation and session, and go down to transport, and network will be say the internet, and the network interface will be the data link, and physically, so will be the cable data links will be a part. And for the TCP protocol, so right here the application including the DNS and then DHCP, HTTP, okay, Telnet or FTP. So this one will be just extra information. just like for own interest. Okay, for transport layer, we talk about TCP, UDP. Okay, when we talk about, if you remember, like using a UDP, the sending. Also, internet contains the IP, IPsec, and ICMP and the ARP. Okay, just through the protocol or the IGMP. So all these belong to it. And network interface, we have the serial line internet protocol, SLIPE, or like purchasing power parties like PPP. So, but this one pretty like outdated a long time ago. The reason why we try to analyze the data package, because we can sometimes it can be helpful like for us like to detect the network problem, or sometimes what's the bottlenecks. Okay, why it goes so slow. And also we can detect the network intricacies. Okay, also we can gather some like network statistics. So this all of these that can help. There's some like protocol analysis that help us to like capture or decode the data package like travel on the network, so we know. So we can like read it and know, okay, which one sequence that we sending this, what's the data payload, or sometimes what kind of commands they try to send. And when we try to capture the data on the network, then you need to have some like basic understanding. Sometimes most of it just like a mix up of the what's the IP devices, like which one should I check. Okay, so where they sending to, like traffic of interest, and then what's the internal expert like get generate too much like traffic to NSS internal LAN more. So we have to like monitor. So it's the DMZ. Okay, right here, if you remember DMZ network, or just like some like perimeter firewall. So there are different type of firewall we can capture. So through the we have the private LAN. So if you remember, like sometimes we set up the through the public network, that we set up the VPN. Okay, how about VPN? So how can we capture between all these? And that capture like for the packet, then for NSA, we already try to create a baseline, and those like we try to capture all these, like start with a baseline, capture all the packet, and then start to analyze it, and then try to investigate or resolve those like. So all the steps involved, including like what's the maybe the measures, okay, or like response time, what's the percentage of the package loss. If you try to like sending package, you can like they will tell what how many package loss, or like what's the TCP UDP connection, like when they start or end. So all this can be analyzed. Okay, how long is the connection. And for the logging, when we try to examine the package or logging, so for the normal ones, or maybe connect to the FTP server, and then we use the DNS, the FTP in the UDP. So maybe also there's like three-way handshake complete. So all these like we can start to examine those like package. If they are those like package showing the evidence of the port scan, so maybe they have a serious like TCP package, or like it's a part of the three-way handshake, or maybe there's some segments within like segments, so they arrange it in the sequential like order, so of the source port, and maybe the destination port too, like if they in the sequential order, so we need to like search for a metric. And also we have some like classic TCP port scan. So all these will be the basic steps we can examine the packages. Okay, so to showing the evidence. And so far, just quickly we go through all those network. Okay, thank you.